Welcome to Oncology Data Advisor, where today we're continuing our coverage of the 2025 ASCO Annual Meeting. I'm joined live from ASCO by Gayathri Namasivayam, who is a Senior Manager of Data Science and Machine Learning at Ontada. This weekend, she presented her team's poster entitled Use of Large Language Models to Extract Cancer Diagnosis, Histology, Grade, and Staging from Unstructured Electronic Health Records. And now she's here to tell us a bit more about this work. Gayathri, thanks so much for coming on the show today.
Thank you. I'm a senior manager for data science and machine learning at Ontada. I lead the efforts to extract clinical information from patient documents. Um, I've been working at Ontada for the last 5 years. This project, something that is very exciting because it it is going to improve the data, the quality, and the accuracy, and the completeness of our data. So I, we've achieved very good results, and excited to apply the same technique to other domains.
Awesome. Thanks for introducing yourself. So, for background, what kinds of unstructured documents are there in electronic health records, and how could extracting their data improve completeness and accuracy of the EHR?
Yes, we have two primary sources of unstructured documents. One we call them as progress notes. They are just plain text documents. They have a lot of information about the patient's medical history and interaction. The second kind of documents are PDFs. They house a variety of documents, which includes patient um, reports from like imaging, biomarker lab reports, financial documents. It could have pathology reports. Sometimes these PDFs are outpatient records, and they have, a lot of documents combined as a single PDF. So the PDFs also are quite often just scanned documents. So that means that there's no underlying text layer. So meaning you cannot really extract the value, and the key from the document directly like you would do in a regular PDF. So, these are, the two main sources of unstructured documents that we see in the EHR.
Perfect. Thank you for explaining. So, how did you and your team decide to approach this gap, and how did you go about developing this solution?
We started out by looking at what we wanted to extract, right? And we looked at all of the different approaches, right? And we evaluated the different machine learning approaches, and we identified uh, this one approach to work the best with the least amount of uh, errors, right? So I think it's more like starting from the problem statement, uh, extracting annotated data, validation data, and then building machine learning models or evaluating current machine learning models, and then choosing the best model or the pipeline that works for us in order to achieve the highest F1, which is both. I think we ended up with the most recent advances in artificial intelligence, which is large language models. Even with large language models, we use the technique called prompt engineering, right? Which are natural language prompts that guide the large language models to extract clinical information um, from from the document. So we found good success with this recent approach.
Wonderful. So, how did the pipeline work? What data did it extract, and how reliable and accurate was it?
So, like I mentioned earlier, we have two primary sources, right? One is progress notes, the other is PDFs. So for the PDFs, we specifically had to first start out by doing an OCR. For the progress notes, the data was already in a text format. So we converted the PDF data into a text format by doing an OCR. We used Azure Document Intelligence Read model to do that. And after that, the next part of the pipeline um, is to create is to take that document and also add to it the prompt. The prompts were built by the data scientists, um, and we combined that, sent that to the LLM, and then extracted the relevant information from it, clinical information. How we actually validated this pipeline is by just randomly sampling a set of documents from the pathology documents from the PDFs, and also a random sample of the progress notes. And we had chart abstractors manually review and extract the information from it. We then parsed the same set of documents through our pipeline and then compared it against the chart abstracted output, and to determine the precision recall in F1. We achieved an F1 greater than 0.85 on all of the clinical information that we extracted from these from the the PDF, which is the pathology reports and the progress notes.
Wonderful. It's great to hear. So do you have any next steps for the pipeline or plans for how it can be used going forward?
Yes, I think since we achieved success on extracting these specific clinical information from the pathology reports, we are applying the same pipeline to extract other relevant clinical information, like metastatic sites, and also applying it to other domains, like extracting results from biomarker reports or genomic reports, and to domains like imaging and treatment and so on. So yeah, we're looking forward to extracting much more information, and increasing the completeness and accuracy of our EHR.
Awesome. That's really exciting. So as we wrap up, anything else you'd like to add or any take-home messages about this work for our audience?
Yeah, I think that this pipeline is very simple. It's something that can be applied to different kinds of documents, and I would encourage that if there is a similar use case, that that we could really apply the same pipeline. Our documents are quite varied, and we have data from several practices, and I think that this pipeline might work quite well on different sets of documents as well, coming from other practices, and it might just need a slight tweak to the prompt, but overall, I think this pipeline is quite robust and can be applied in different settings.
Thank you so much for coming on today to tell us all about this pipeline and how it's being used. It was really wonderful to hear about your work.